Hi everyone, my name is Nathan and today we're going to learn how to use WebODM. This tutorial will cover everything from uploading pictures to georeferencing to downloading a usable product. What you're seeing here is a textured model of Carleton University's parking lot P6, and this is just an example of what you can create using WebODM. This is part one of a two-part series where in the second part, we will use some of the products created today in WebODM to perform an accuracy assessment using QGis. So without further ado, let's get started. So the first thing you need to do in order to use WebODM is to obviously download WebODM. So if you just search up WebODM, you can hit download. And this will bring you to the WebODM page. There are two options to download. There's the WebODM installer, and this is a version that will install WebODM for you, but it does cost $57, I believe. So yeah, there you go, $57. So what we're gonna do is we're gonna do a manual install. And this might be a little intimidating because you have to download quite a few additional features and it doesn't do it just for you, but the instructions here are really quite good. And if you just scroll down, here are the instructions. There are also videos that can do walkthrough like that. I will link a video so that if you are not confident with reading through these instructions, you can go there. But other people have already done that, so I'm not going to rehash it. And we're just going to get started with WebODM. So once you have WebODM downloaded, it is time to launch it. So if you're using a Windows machine, you've got this Docker desktop here, and you can launch WebODM through this. So you just go to WebODM. You can see that it's running. I'm going to go here, Web App. And what you're going to do is you're going to hit Open in Browser. So WebODM, it just kind of has a wrapper around it for the user interface that runs through your browser. So I'm just going to hit that. And it is going to open a new browser. And there you go. Here's WebODM. As you can see, I have a whole bunch of projects here. You don't need to launch it through the Docker desktop. Alternatively, you can just search localhost 8000 in your search bar, and that will pull it up. So now that we have WebODM launched, it is time to get started with the image processing. Before we begin processing the data and the images, we need to make sure the images are ready for processing. So to do that, I am going to use ExifTool to check the Exif data. If you don't have ExifTool, it's really quite easy to download. You just go to exiftool.org and you download the correct version for your machine. So once you have it downloaded, you can use it to examine the Exif data. For instance, here is the set of photos we're going to use later on. And I just have the photos here, and I've got the Exif tool saved in the same file or same directory as the photos. So let's just check out the Exif data. I'm just going to drag this photo on top of ExifTool, and it is going to launch a command line looking system. And this brings up all the data associated with this picture. So as you can see, it's got the GPS accuracies and among other things, as well as the camera parameters. It's got the time and it's got all sorts of data associated with it. So there is one thing that is missing though, and we are going to use ExifTool to update the DOP value, that is the dilution of precision. And I'm just going to go over quickly how to do that. First thing I'm going to do is I am going to rename this ExifTool here. So I'm going to get rid of this -K. And then I'm going to open up command prompt as I need to run it through the command line. So I'm just going to pull it up here. There we go. So here's command prompt. Now I just got to navigate to the correct folder, not this one, but this one. All right. So the way I'm going to do that is I'm just going to change directory. So the code for that is CD and then the directory I need to get to. Gonna hit enter there. So now I'm in the directory with the photos as well as the ExifTool. And now I wanted to update the DOP. So that's the dilution of precision. It just decides how much WebODM can move the camera because all these images should be tagged to a certain precision. And that should be, for the equipment we use, 3 centimeters, but there was a glitch that occurred and some of the photos are tagged to 25 centimeters. So what I'm gonna do is I'm going to use this code here. So what this does is it's running the ExifTool. It's setting the GPS DOP to the GPS Z accuracy. So this could be a fixed number, but in our case it changes. So what we're going to do is we're going to do all the images at the same time using the same line of code. And then I've got a dot, a space, and then DGI asterisk. Asterisk is like a wildcard, so that could represent any of the pictures. As you see, the numbers change here, but the ending's the same. So we're doing .jpeg. And now all I'm going to do is hit enter. And there we go. As we see, it's reading through all the files. There are quite a few files here, so it takes a minute. And it should be updating the dilution of precision. I've already done this. So as you can see, it read through the files. It didn't update any files, but it read through them. So now that the Exif has been updated, we can close this and we're ready to bring these images into WebODM. To bring the photos in, we need to first make a new project. As you can see, I've got a bunch of projects going on, but we're going to do a new one. And usually you want a descriptive title, but I'm just going to call mine demo. And I'm going to put in a few things in the description. So in the Exif data, we used the DOP. So I'm going to write with DOP since we just updated that. And I'm also going to write without ground control points. Now, when I went out and collected this data with the drone, we did use ground control points. So I will show you a demonstration on how to use those ground control points. But when it comes to running it, since it does take a while and a lot of processing power, I'm just going to do one full run through without the ground control points. So let's hit create project. There we go. It's brought up my demo. Now it's time to select the images and the GCPs. Not using GCPs, obviously, so nothing to select there. But I'm just going to scroll to the bottom and highlight absolutely everything. And then I'll unhighlight this file there. Now I'm going to hit open. And it hasn't brought in the images yet, but it does know where they are, so they're ready for processing. We need to adjust some settings. So I've got this preset that I usually like to use, but it's not quite right for this task. So I'm going to hit edit task options. We're going to scroll down. Most of these settings you can just leave in the default setting, but there are a few you need to change. So DSM, so this is a digital surface model. We do want to produce this, so I'm going to enable that. We also want to produce a digital terrain model, so I'm going to leave that enabled. We're also going to set the feature quality to ultra. I have a very powerful machine, so I'm willing to go ultra. If your machine isn't super powerful, you can run medium, low, or lowest. You'll still be able to participate in the entire tutorial. Here's an option here that's interesting, force GPS. So you can use the GPS Exif data for the reconstruction, even if there are GCPs. So what this will do, it'll ignore the GCPs and just go straight for the high precision GPS in your Exif data. We, of course, aren't using GCPs in this case. So I guess by extension, it's already forcing the Exif data GPS. Here's another thing we're going to change. See this GPS accuracy? So right here, we're going to set the GPS dilution of precision again. I know we already did this in the Exif data, but we're also going to do it globally. So here I've got it set to 0.03, which was appropriate for one of my sets of data, but it is not for this one. I know for a fact that some of the images are tagged with 25 centimeter accuracy. So what I'm going to do is I'm just going to set this to the 25 centimeter accuracy. As you can see, the default is 10 meters, which is absurd, but that just gives WebODM as much latitude as it wants to move move the images, that is, if it doesn't have the DOP set. But I'm going to set it to 25 centimeters since I know that's the worst accuracy that we have. We're going to scroll down, just take a look at all the settings, make sure everything's good. So most of this, I'm just leaving default everything. All right, so here we're going to output a LAS file. It does by default output a LAZ file, which is a compressed LAS, but might as well get the full thing because some programs don't natively support the use of LAS without first turning it into a LAS. So we're just going to get that, and it really doesn't cost much more processing time. And then I'm going to set my PC quality to ultra. I have a pretty powerful machine, as I stated already, so we'll leave it there, but you can run it in any other setting. Default is medium. Keep scrolling. Let's just look at all these settings. I think that's everything that we need to change. So we'll take a look at this. So there we go. That'll also overwrite the GCP data. All right, so I'm going to save that, and then we'll get to running it. Before we run it, we have to review our settings. So we hit review. So we got our digital service model, digital terrain model, feature quality ultra, GPS accuracy set to 25 centimeters, LAS file output, PC quality ultra, and that's exactly what we need. So I'm just going to hit start processing. First thing it does is it uploads all the files here. And yeah, as you can see, there are 271 of them. And while this is running, let's just go through how to use GCPs. In order to use GCPs, obviously you need to have GCPs. So on the day of the data collection, this means that you need to go around placing targets and then measuring those targets with a high accuracy GPS. We did do that on the day of our data collection. So we do have that option. And I know a lot of people are going to use that method. So we're going to show you how it's done. So first you go to this GCP interface. And as you can see, it's got this direction tabs. And this just gives you a few instructions on what you have to do. But first things first, we need to have our GCP file ready. So as you can see here, I had a few different GCPs. I've got it tagged with the X, Y, and then the vertical. And then at the top, I have the projection required. The formatting is very important. If you don't format this correctly, WebODM will not be able to recognize it. So this is the way you have to have it. So I'm just going to minimize this. I'm going to go back to the file and I'm going to drag it into the load existing control point file. Brings it up like that. I'm going to hit load. And as you can see, it brings us right to that parking lot on Carleton's campus. Next thing we need to do is we need to upload some images to be used with those GCPs. I'm not going to upload all 271 images. I'm just going to upload a few for demonstration that I know have GCPs in them. So I'm going to upload that one. Then I'll upload this. And then I'll just take a few more. You know what? I'll just grab a chunk of them here. And these should have at least a few of the GCPs. I'm going to drop them in. And then what we're going to do is we're going to go through these images and we're going to pick out the appropriate GCPs. So starting with this first image here, I'm going to click on it. And I'm just going to move the image around and I'm going to move the GCP around. So we're not using this. I'm actually going to remove this because it added it erroneously. And delete that, and I'm just going to move that. So over here, there's our first ground control point. I'm going to zoom in nice and close, and I'm going to place this as close to center as possible. And then I'm going to select the same ground control point on the map over here. So I know it's this one. There we go. Green means they are tied together. Just like that. But I'll deselect it. There we go. Green means they are connected. And that is center. And we'll do this in a few more images. So now when I move this, that ground control point stays stationary. I'm going to come over here. Here's our second ground control point. I'm going to click this button. Zoom in nice and close. I'm going to place that on the center. I'm going to tie it to this one. So green means good, and it's fixed in position now. So I believe that is all the GCPs for this image. I'm going to go back, and we're going to do it on the next image. Select this image here. Sometimes it just erroneously adds one. We're going to move around. Let's see, where are those ground control points? So here we go. Here's one. This is once again ground control point 2, the green one that we did. Zoom it in nice and close. Right in the center. Select that. Well, I'll deselect it first. Got to make sure it goes green. There we go. Now it's selected. Zoom out. And I believe that's all the ground control points for this image. And then we'll go do on the next image. I'll do it on a few more, and then I'll check back in on the last one. I'm tagging GCPs in one more image here. And while we're looking closely at this image, something important to note is that this imagery isn't straight down. It's on a slight angle. And we actually ran 2 different flight paths with the angles going in opposite directions, so perpendicular to each other. And the reason for this is because running the camera at a slight incline, in this case, I believe we did 10 degrees, it helps reduce the error due to doming. So doming, simply put, is kind of like a fisheye effect that you see on wide angle cameras. And having doming can affect your vertical values. So we run at a slight incline. And I'm just going to tag the last GCP here in this photo. There I am with the GPS actually measuring the GCP. And I'm going to just add the tag there. And that should be this one here. So now I have all the GCPs tagged in at least one photo. And I've got, looks like 20 some odd pictures here. So once everything's tagged, I'm just going to hit export file. And what this does is it makes your GCPs into a text file. And as you can see, it has all the information there. So what we're going to do is we're going to save this. And we can also copy it if we want, but we'll just save it. And here's our projection. That is the same projection we inputted with. This is just a different way to define it. So I'm just going to hit save. And it's going to ask me where to save it. So I'm going to save it. Sure, here looks good. And then we can bring this in later. We're going to go back now to the dashboard. And as you can see, what we ran earlier has finished. It took 57 minutes on my machine. And just to go through the full GCP process, we're going to add a new project. I'm just going to name this GCP, no description, since I'm not going to bother running it. We're going to select images and GCPs. So here we're in the same file. I moved that outputted GCP text into this file. And what we're going to do is we're just going to select it all at the same time. Deselect that. Open. There you go. Now it knows where the GCP file is and it will read it in. As you can see, this now says 272 files selected. So that's the 271 pictures plus the GCP. And we can go in and we could edit these settings and we could run it if we want. But for now, since I already ran the other process, I'm just going to hit cancel. Just like that. And then we'll go over here and we're ready to get our outputs. Before grabbing our outputs, just one more quick note on GCPs. So the main advantage of GCPs is that you don't need high accuracy GPS actually attached to the drone. You can use the GCPs on the ground to do all of the georeferencing for the image. You can also use these GCPs to improve the georeferencing of the image. So they can be used in combination with the high accuracy GPS attached to the drone. And that might reduce things like bias and related to surveying error. So sometimes there is like a vertical offset that occurs and that needs to be corrected. But through the use of GCPs, that should reduce that vertical bias to a negligible amount. So now that it's done and we're done talking about GCPs, let's take a look at our product. So I'm just going to hit view map. and that is pulling up our ortho photo. As you can see, it's extremely high resolution. That's just because we used a very good quality camera. And if we zoom in, we can spot those GCPs that we tagged earlier. We can also have a look at a 3D model. So this might take a second to render. There you go. So that is all 34 million some odd points. And as you can see, there's some vertical change. You can also see the light posts kind of floating there. And if we want, we can apply, the textured model. So we hit show model. And what this does is it just kind of renders the surface, makes it more photo quality. It does get rid of some details like the floating light standards. But as you can see, we can see things like the parking lot's curvature. We've got a bunch of cars here. And yeah, so that is a 3D model. Now, you can't do a whole lot with it within WebODM. It gets really powerful when you can export it and do processing in another program. So we're just going to go back to the dashboard here. And let's have a look at our various outputs. So I open it up, and it gives me some stats on it. Here are the options we picked. It gives me the average ground sampling distance, which is the distance between points. So that is 4.89 centimeters. Gives me the area, and it shows that there were 34 million some odd points reconstructed. So that means each of those points has an X, Y, Z value, and they are georeferenced in space. So over here at download assets, we can see all the different products we got. So there's that last file that we chose to output. What we're going to use in part 2 is going to be our terrain model and our ortho photo. But as you can see, here are other things. We can get the texture model, camera parameters, the camera shots, which is the location where those pictures were taken. So those 271 pictures. It also has a quality report that can give you information on accuracy and various errors. There's also an all assets download button. So what all assets will do is it'll download everything here, but it will break up your LAS and LAS files into chunks so you can have different tiles. But we're not going to be using those right away. Those can be used in a lot of different programs. You can use them in QGis, Esri products, or R for processing. But for the processing we're going to do in part 2, we're just going to go for the surface model. So I'm going to just hit download on those. So we'll start with the surface model. Ask me to save it here. And then we will download the ortho photo as well. Save that there. There we go. Now we're ready for part 2, which is our accuracy assessment. So thank you very much for listening to part 1, and I'm looking forward to showing you what we can do with the data.